Hello, everybody, and welcome to the final session today for the new technology stream. Just a little few house rules. The session is being recorded, and hopefully you'll be able to get the record after the session. To do that, you've got to basically sign in. I should actually introduce myself. My name is Jeff Eggleston. I'm chairing the session. I work for IBM in the hardware division. The other thing that I would also like to raise is questions. We would like to try and make it quite interactive, and we would like to encourage you to put messages on the chat and we can involve you. So please, there's no stupid questions. Just please fire away with questions. So to that end, what I'm going to do is I'm going to hand it over to Vaughan Marshall from Broadcom, who is going to be talking about developing for mainframes the Git native way. It's all yours, Vaughan. Have a good day.
Thank you. So welcome, everyone. My name is Vaughan Marshall, and I am a product manager at Broadcom in the mainframe software division, responsible for various DevOps products. And as Jeff said, what we want to do today is talk about how you can develop for mainframe using Git natively, meaning using Git without any interaction between other SCMs or things like that. Just basically purely using Git for your mainframe development. So I'm going to talk about that. I'm going to show you what that looks like. And I'm going to talk about some of the considerations. So let's go ahead and dive in. And as Jeff said, if you've got any questions, please pop them in the chat. I'd be happy to take questions all along the way. So let's move forward. So of course, this is just a disclaimer saying that anything we say is informational, can change at any point in time, specifically if we're talking about any features and any products that we maintain. So to get started, let's talk a little bit about Git and what it is and why it might be relevant for mainframe development. So hopefully everybody has heard of Git, but if not, it's essentially a version control system that was invented by Linus Torvalds to work on the Linux kernel. And the reason that it was invented is that Linus had found that there was a number of shortcomings with the way version control systems work, namely the whole idea that you would be using kind of we'll call it a gold copy repository, and then everybody would connect to it and work online from that. Obviously, with a widely distributed developer community for the Linux kernel, they needed something where people could work independently. So we came up with this concept of distributed version control, where everybody has a full copy of the version of basically the repository on their laptop, and they can trade snippets back and forth. It has become wildly popular. There are many different enterprise Git platforms now, but they all use that same protocol. And as such, it's kind of taken over the world of development to the point that you could call it a de facto standard. Essentially, whether you're using an online Git repository like a GitHub or a Bitbucket or GitLab, doesn't matter. They all work the same way. You can work with your own copy of the repository on your machine. You can do operations like pushes and pulls to trade code back and forth. And of course, the centralized server, you can connect to at any point in time and upload your code or get other people's code. One of the reasons it's become so popular is because it is very easy to integrate other people's code. You can almost do automatic merges, if you will. It's very good at tracking and collaborating. And of course, the enterprise Git repositories bring that to another level with things like pull requests and web-based browsers that let you browse through the code. So anyways, given that, a lot of organizations are wondering, hey, can we leverage this de facto standard, if you will, to make it a little bit less of a learning curve for people basically being tasked with maintaining mainframe code, especially when we have a new generation of developers coming on, because it's a very common skill set. Everybody used it in school, and also because you would have an enterprise standard. Whether you're working on distributed cloud, mobile, or mainframe code, doesn't matter. You would be working the same way. So the answer, of course, is yes, you can use Git for mainframe development. And so that's what we're going to talk about today. So I wanted to also just have a quick compare and contrast with the way people have traditionally worked with mainframe SCMs and how it looks with Git. So the first thing I'll point out is that typically when we're talking about mainframe SCMs, code is developed on trunks. People will lock a particular version for their use. They'll do their development, they'll unlock it. Other people might go and build things on top of it. There might be some degree of parallel work happening. Usually it's at a release level, but in the Git world, that's actually taken because of the ease with which you can merge things to a different level where you have a feature. Every single feature or defect will be worked on in its own branch and the work will be isolated. The advantage of that is you avoid intertwining your code, which makes you more agile when it comes to delivery. So if somebody's not quite ready and you're ready, you simply, merge your onto the trunk and you can promote your code up and start testing it. And you don't have to worry that maybe you developed on top of something somebody else did, and now you have to wait for their code to be fully finished before you can promote. The other thing too is that because you're working on an offline copy on your laptop, you are effectively never blocked from working on the code, right? The sign out is effectively an exclusive lock, whereas when you're working on your laptop, you can make whatever changes you want, and then you deal with any conflicts by merging. And again, as I've said, that the integration of code in the workspace is very, very slick in Git. You don't have to manually merge. Very often you can get away with an automatic merge and so on. Another thing that enterprise Git SCMs bring to the table is something called a pull request. Essentially, a pull request is when you go and you bring your change up to the main repository, you put it out on a branch, and a pull request is a request that somebody will review that branch and bring it onto the trunk. And that can be brought together with an automatic and enforced code review and other things. You can enforce, for instance, code scans. You can enforce that a build is completed successfully, and so on. So that level of protection on that main branch helps to keep things running smoothly. Another thing that you will find in traditional mainframe SCMs is very often there's an application monolith. Everything is all together. People are often working on maybe a portion of the code at the time, but through concatenation, everything else is brought from up the map inside of the mainframe SCM. And so it can be somewhat difficult to figure out where the boundaries of an application begin and end. In an enterprise Git repository, everything's in the SCM, and it's typically carved up by application. Maybe you have special repositories for dependencies, but it's a lot more, segregated, if you will. So you don't have this monolithic architecture. Okay, so let's look a little bit at the what the enterprise stack of tools looks like when you're working natively with Git. So, very often in a traditional SCM, you will find that everything that I've got here on the page is provided by that one tool, right? You make changes in the tool, the versions are tracked. When you make new changes, the builds are done automatically. And then, of course, the binaries that are output are managed by the tool, and they can be packaged up and deployed through life cycles. Whereas in the enterprise stack of tools, this is often broken up into different sets of tools. So for instance, a flavor of Git, an enterprise Git repository will provide the version control. You may have a different tool that does the builds or orchestrates the builds on changes. These are typically called continuous integration tools. So things like Jenkins, things like GitHub Actions or GitHub or GitLab CI/CD are examples. The binaries that result from the builds are often put into a separate tool called a binary repository. So some examples I have here are Artifactory and Nexus. And then something is going to check those binaries out and do deploys into live environments. So Ansible, Urban Code Deploy, maybe helped out with Zoe CLI, can do that for you. One thing I wanted to note too is that as these enterprise Git repositories get bigger and bigger and more adopted, they're starting to kind of move into the world of other areas. So for instance, GitHub now has GitHub Actions, and it also has code spaces. So it provides an inline IDE that's part of the web platform. So I think in future, you'll be starting to see the enterprise Git platforms almost come full circle and evolve to something like a mainframe SCM, where it does multiple functions all in one place. But one of the hallmarks right now is that everything is decoupled. Now, when we're working with mainframe code, obviously you can use this stack, but you're going to need something that is able to work with mainframe. So for instance, you're going to need some sort of build tool that can do a mainframe build. Jenkins can't do that, but neither can it do Java builds out of the box, right? It uses another tool like a Maven or maybe an Ant or something like that, or a Gradle. So it calls out to a build engine, and it's the same with mainframe. You're going to need some sort of mainframe platform or language specific build engine. Likewise, on the deploy side, while you'll have tools like Ansible and Urban Code, they can orchestrate on the mainframe, but they're going to need some sort of mainframe specific agent, if you will, or they're going to have something that can talk to mainframe like a Zoe CLI. Okay, so the tool stack can be used very well and effectively with mainframe, but you do need helpers, if you will. Okay, so let's talk a little bit about Zoe CLI, what it is and why it's helpful. So Zoe CLI is essentially a command line interface that takes inspiration from things like the Google Cloud Platform's API, where you have the CLI talking to a remote compute platform via API. And because it's a CLI, it can simply be scripted. And so it doesn't really matter what kind of orchestrator you use. You can use GitHub Actions, you can use Jenkins, and it can call via the CLI the APIs on the remote compute platform, in this case mainframe, and it can then essentially affect the operations on that platform. So whether it's uploading a file and then running a job or things like that, Zoe CLI can be a great leg up. So I do see a question.
Yeah, thank you. That's why I've come. That's why I've come on the video to highlight
there we
that.
go.
Yeah.
So
okay,
let's go
great.
ahead. So this is a comment. It says, we seem to be introducing a greater level of complexity with the typical enterprise stack. Is that introducing greater technical debt for the future? That's a good point.
Can I stop you a minute? But can I stop you, Vaughan?
Sure.
By the way, everybody, what I've done is you can actually unmute yourself if you wish to talk as well. So you have the capability of unmuting if you want to go in. So I've just done that. So sorry to interrupt, Vaughan.
Not at all. Not at all. Yeah, no, that's a great comment and question. So, maybe I'll even go back a slide here just to kind of talk a little bit about this. On the one hand, I would agree. Yes, you've got more moving parts, right? And you have to figure out how do these things all fit together. And that means that you're going to have to, have people with different levels of expertise and different tools and so on. Now, that said, there's a couple of advantages. The first being that you avoid what is typically referred to as vendor lock-in, right? So you don't have one vendor that is, essentially controlling everything. It helps from an end user perspective or a customer perspective to be able to have that choice. They get to use the best tool purpose-built for whatever's going on. So yes, at the cost of more complexity and more administration. The other point that I would make, though, is that, as I mentioned, the Git providers seem to be kind of moving into this world of, very similar to how mainframe SCMs were in the past, all in one, right? So, GitHub has GitHub Actions now, so it's kind of all built in. And you can usually, in the Git platforms, there's a marketplace with an ecosystem that you can extend. So to some degree, it seems like we're naturally evolving away from that complexity. It's there if you want it, You can have a completely heterogeneous stack, but you can also be, you know, an all-in-one platform if you want. That's a good point, worth considering when you're making decisions. But you know, I would say that there's both options kind of available. Okay, so thank you for the question. So talking about Git native stacks, so one of the things you'll see, you know, obviously there's many different IDEs out there, and in fact, one of the advantages of Git is that, you know, Git almost is, again, a de facto standard. So every IDE you find out there pretty much guaranteed to have a Git integration. The big one these days is VS Code. I'd say there's kind of two IDEs that are, you know, viable in the world of mainframe, or that have the supporting pieces for mainframe. So for instance, you know, language editors for COBOL and so on. They're either Eclipse based or they're VS Code based. The Eclipse based ones work well with Git. They have a plugin in Eclipse called eGit. So if you want to use that, you absolutely can. VS Code, though, seems to be the one that everybody is gravitating towards. It is lightweight. It is easy to maintain. They have a great marketplace. You can put in whatever you want, and you can use it for mainframe. And one of the reasons it's becoming, again, almost a standard, or at least where things are going, is that it is written in web native languages. So I mentioned GitHub has something called code spaces. This is essentially the ability to run VS Code inside your browser, backed by a containerized dev workspace. So I foresee a future where people will go into their Git repository, they will spin up their branch that they're going to work on, and along with it, they'll have a web-based IDE that has all the tools they need specific to the stack that they're working on. So that's another aspect of this, is the IDE. All right, moving along. So some considerations around Git specifically for mainframe. You can use it for mainframe. There's nothing that prevents you from doing that. There are Git clients out there for mainframe. Rocket has a port of Git that runs on Unix system services, and there are even ISPF Git clients out there. So if you are an ISPF person who prefers, you know, to work in ISPF, doesn't quite comfortable, you know, that's your IDE of choice, if you will. You can absolutely use Git with that through an ISPF client. You know, some things that I had mentioned in the beginning, mainframe monoliths might not work well all in Git. So if you've got, you know, millions of files in your traditional SCM and you just try to put it into a single Git repository, you may find, for instance, that when you're doing Git clones or things like that, everything grinds to a halt. So you need to kind of break up your code into applications, and that might be tricky. Obviously, if you're putting code in Git, that's great, but you still need to build it. So you're probably going to have to figure out, how am I going to build this code? You're going to need some sort of build engine for mainframe that the Git native stack can call. If you're running a CI/CD tool as part of your stack, you need to figure out whether or not you need an agent or a host or some sort of runner that can run on the mainframe. So for instance, GitLab has runners for ZOS, so does Jenkins. They have an agent as well, but not all of the tools do. So you'll have to consider that. You'll also want to figure out, you know, if developers are working, how do they run builds of their working directories? You know, is it something that they can do from their laptop if they want to work on, say, a VS Code IDE? You know, how do you test? That's a big one. When you have tons of branches, that's all well and good, but ultimately you need environments. So do you have virtual LPARs? Are you using a tool like ZD&T? Can you spin up test environments, or do you have a static amount of test environments? And then the last one is kind of speaking to culture change. Does everybody want to use Git? Not everybody does. So, you know, there's different approaches I'm going to talk about. We're going to show the Git native way, but I just want people to be aware that we have different approaches out there that can maybe help deal with some of these specific considerations. CI/CD is another lifecycle automation. I talked about build, but packaging, promotion, all those things need to be considered. And of course, the question is, can you use hybrid approaches to make life a little easier, especially as you're moving towards a Git native future? And again, culture change I mentioned earlier. The best way that I've found in terms of dealing with it is to go slowly and in manageable chunks. So, you don't want to boil the ocean, reinvent everything, and force everyone to change. That's going to cause a lot of disruption. So you want to consider, are there ways you can go team by team, app by app? Are there ways that you can layer on new processes transparently, or allow people to still use their preferred interface? If it's ISPF, maybe, like I said, it's one of those Git clients for ISPF, and so on. So all considerations when you're on this journey. So just a bunch of different approaches that you can consider. So this one here is, we call it modernize in place. And essentially what this is you're treating the new stack as an interface on top of the traditional SCM. You're using tools like Zoe to layer on new things or to drive existing automation. And you're using some sort of sync between Git and your traditional mainframe to allow people to use their version control tool of choice. So this is less disruptive. It means that there might be some limitations. You have to deal with, the sync potential problems, conflicts, and so on. There are products out there that you can use for this. But ultimately, this is a less disruptive way to start if you're just getting started. The approach that we're going to look at today is kind of the end state, which is, hey, I'm moving everything from my traditional SCM into an enterprise Git server, and I'm now just using this tool stack natively. Again, you'll still need a mainframe build tool and potentially something for orchestration. Tools like Zoe CLI will help, but nonetheless, this is kind of giving you the most flexibility, the most modern way to do things. You can branch to your heart's content. You don't have to deal with sync issues and so on, but you do have other challenges that you have to figure out, like the monolithic applications and so on. And you can also have a hybrid approach, and this is something that maybe is a step between. So for instance, maybe you move to a approach where you are using a new build tool for developer builds, and either you are checking into Git and then doing sync for a production build, or another approach is to do your production build with the new build tool, but then add it back into your traditional SCM as a binary so that you don't have to reinvent not only build, but also deploy at the same time. So these are just different things that you can consider around your journey, but nonetheless, in the end, I think you'll find that once you get into Git, there's a lot of advantages there. All right, so any questions before I jump over to a demonstration? While I'm waiting here, I will share out my demonstration environment if I can find the share. Here we go. Okay.
Okay, there's no questions at all, so good, yeah.
Okay. No worries.
Carry on, Vaughan.
I shall. So hopefully you can see this. Can everybody see a Git screen? This is GitLab.
Yep, I can see it. It's on both my sessions. So yeah.
Excellent. Okay. So before I get started, I'm going to do a little tour of my environment that I've got here. And essentially the goal here is to show what does Git native development look like for a COBOL developer. So I'll just do a day in the life of a COBOL developer. I'll walk through, the various steps that they'll take. But I wanted to kind of give a tour of the environment and what's managing all the things that are happening. So I'll start here. This is GitLab. And as you can see in GitLab, I have a bunch of files in my repo. I have actually, as a matter of fact, not just COBOL code. If I go into the back end, you can see over here. There we go. There's my COBOL programs. I can click in and see the COBOL code. But I also have, if I go back out to the top level folder, my front end Java code. So this is a repo that basically represents an entire application, front end, back end, a full stack. You could, of course, carve that up differently, but this is my little demo application for a fictitious home heating oil company that basically manages home heating oil deliveries to customers in the northeast of the US. And we've got a little web front end over here. Just like many applications in the world of mainframe, they've been fronted with new interfaces. And ultimately what this does is it allows drivers to record a delivery to a customer. And I've got a little message here popped up from a delivery I submitted earlier, and it's saying hello world. So maybe the use case that we have is to get rid of the hello world or to change that message somehow, and we'll see that happen. In addition to this front end code that I've got in GitLab, I've also defined a continuous integration flow with GitLab CI/CD. So you can actually see over here how this is defined. This is defined through something called a GitLab CI YAML file. And if we click in, you can see it has a bunch of different stages. And in fact, the first stage is to build the mainframe code. Okay. And basically what I'm doing here is I am using a mainframe build engine called Team Build. And effectively what this does is it allows me to synchronize my working directory, in this case in the CI tool, to a location on the mainframe, and then invoke a build of whatever's in there. So it's a tool that's that can build COBOL. It's aware of dependencies and things like that. I then have a stage here called deploy mainframe, and it's using Zoe CLI to simply run some JCL that will take the binaries that I produced in the build step and deploy them to a Kix region, and then do a Kix new copy. And then over here, I'm using Maven to do a front end build. So you can see these are all just command line calls. Zoe being the command line interface that allows me to invoke things on mainframe, or I can run builds, or I can run Maven builds. But basically, whenever changes are happening in my repo, the CI tool, which is built in, is going to pick up on that and invoke builds. And you could add other things in here. You could have source code scanners. You could have unit testing, etc. So they can be all part of that pipeline. In addition to having this repo set up, I've got this code base checked out over here in VS Code. So this is my VS Code repo. Close that. You can see on the right that I've got the backend code open, right? So this is the same thing. There's the CI tool. There's the front end with all the different source. And I've also got installed in this some editors that allow me to work with COBOL. So for instance, if I come in here and I open up, say this guy, right? You can see I've got code highlighting. If I come in here and start typing, I've got code autocomplete. I can hover over things like variables and get a snapshot of it. I can also peek the definition if I want to jump to where those things are defined. I can also even get a view of the flow of the program, if you will, and jump around in it. So you know, tools like this or extensions are available in the VS Code marketplace, and they help you you know, essentially get your VS Code IDE, if you will, ready to do whatever task you're doing, whether it's mainframe development, COBOL development, you know, high-level assembler, and so on. There's extensions for debugging on mainframe. There's extensions for Rex. There's extensions to recognize JCL. And of course, you can see over here, I've got Zoe Explorer. Zoe Explorer lets me navigate the operating system. So for instance, if I wanted to see any jobs that are running, I could look in the jobs section, or if I wanted to, let's go to the favorites. Ooh, there we go. If I wanted to look at different libraries that I have set up, for instance, I've got a JCL library over here, and I can actually navigate. Oh, what's it complaining about? Let's try that again. Sometimes it gives a little error. Huh, okay, interesting. Try this one. There, that one's working. So anyways, over here is my deploy job. You can see I've got all the different steps, right? And it does the syntax highlighting and so on. So that's my environment in a nutshell. Now I'm going to walk through what does it look like to do a small change in this environment. So typically, as a Git developer, the first thing you're going to do before you do anything is make sure you're up to date. So I'm going to go ahead. I'll do a git pull. A pull operation basically goes back to what's called the origin, or the place where you've said you got the code from, in this case, my GitLab server, and it brings any changes that anybody else has done into your repo. And you may have conflicts and things if depending on how you're working, but you always want to start up to date. The next thing I'm going to want to do is create a new branch. And by the way, I'm using the command line here, but tools like VS Code have also the ability to work off of plugins as well. So there's a built-in Git plugin or extension in VS Code. So if I wanted to not use the command line, I could do a checkout to a new branch, which is going to be the next thing I'm going to do, is make a branch. I could use this. So let's do that. I want to create a new branch for this. I'm just going to move some toolbars if I can. One sec. Let me see if that, there we go. Okay, so I'll do a checkout to, and I'll go create a new branch, and I'll give it a name. We'll call this GSC 23, and I'll hit enter. And you'll see down there, just like that, I switched to a new branch. And by the way, you can also get other great Git extensions in VS Code, things like the Git graph that show you, visually what's going on with all your code, etc. You can even do operations from the graph view. But anyways, what I've done here is I've put myself on a branch so that I can work in isolation, right? So if I need to work on something else, I can commit to this branch and then switch branches and start working on that. I won't have code getting intertwined. And the other thing is this branch lives only on my machine at this point. I can publish the branch over here if I want, and then other people can work on it, but it keeps everything nice and isolated. So I'm going to go now, and I'm going to go find that spot in the code where that message is that we want to change. I happen to know it's in Slick PD over here, and I can scroll through, or I could use the navigation. In this case, here we go. There's hello world. I'll change this to hello GSC, and we'll save that. Okay, now the first thing you'll notice is that it's been flagged as modified by the IDE. So it can see, what changes are there. You can also come in at any point in time. You can see the pending changes. You can click this and see a compare. You can work on any number of files here, and it's tracking it. You don't have to keep track of what you're changing. It knows what you're changing. Likewise, if somebody else is making changes out on their repo and they push them in so that they're committed into the trunk, I can integrate those changes at any point in time by coming in here and doing a pull, right? The pull command is essentially saying integrate other people's changes that have been committed into the repo into my branch so that I can see how it plays with the other things before I do my pull request. So in any case, I've got my change pending. The next thing I'm going to want to do is build it. I don't want to commit this without being sure it's going to work. So what I've got here, as I mentioned before, is a tool called Team Build, and Team Build actually has some scripts associated with it. You can see this blue area over here called scripts. This is actually a Git submodule. So I'm pulling in scripts from a centralized build scripts repo, and I have the COBOL builds. The linking in there, it's all set up in various scripts, and I can drive it through this build Z script that I've set up for my repo. And essentially this defines my build. Okay. So this is the tool that I can use to build. Now, when I want to build it, I have this handy shell script over here, and you can see what it does is it runs something called syncz. This mirrors my changes, my working directory, if you will, out to USS on the mainframe. And I've got that defined over here through this syncz YAML file that tells me, the name of them, the syncz operations, tools, etc. And I've also got a variables file that I can populate for my particular thing. So I'm saying this is my build directory. This is my LPAR that I'm working on, and use this user ID to talk to the mainframe. And by the way, it's using SSH to talk to the mainframes, and I'm using certificate-based authentication, so I won't get prompted for passwords. I can work transparently as though I'm building my working directory here, but it's really happening on the mainframe. So I run that build.sh, and then afterwards I say take the source directory, which is here, and build it. And then finally I can say use this Zoe command to copy the build libraries into a running Kix region, and that will allow me to do a quick test. So let's go ahead. I'm going to do the build. Oops, I'm in the wrong directory here. So let's go to the back end, and then I will run that build script from my built-in terminal. We'll open this guy up. So you can see it synced just what I changed. And you can see it's only building what I changed. So it's aware of what I've built before. And in this case, it managed to rebuild SlickPD and link it into a new load module and then do the copy. So just like that, I was able to build my working directory with my pending change. I didn't have to check it in to the central Git server or anything like that. Now, to prove that that this works, I have a little test that I can run. Let me just move some toolbars again. And I'm going to access that through Zoe Explorer. So this is my little test. This is actually using a tool called CA Verify. It's a green screen record playback. So it's going to test that load module that I did and see if it has the right message. So let's go ahead. We'll submit this job. And I'll click, yes, I do want to submit it. And then it pops up the job number. So I'll click there. And there it is. We can see that this job is active on the Jez queue here. So we'll just refresh, and it's completed. And I can come in and I can look at the output, and we can see that indeed it says hello GSE. So I was able to make a branch of my Git repo, change something small, build it, deploy it to a live Kix region, and quickly test it. And I did that, without a traditional mainframe SCM. Now, what did I need? I needed a Kix region that I can deploy to. I needed, a location on USS where I can build from, but I can do it all from VS Code on my laptop. All right, so the next thing I'm going to do is I'm going to take and merge that branch. So now let's say I'm happy with that test, and we're gonna do a GSE 23 comment, and I'm going to commit this change. Okay, so that change is now committed, and I'm going to publish that branch onto my enterprise Git server. Okay, so now if I come in here and look at my enterprise Git server and do a refresh, we'll just click here again. We should see, there we go. So there's that branch I created. It's now been pushed to the main server, and I can create what's called in GitLab a merge request. This is basically the same thing as a pull request. And this is where I'm asking, maybe a senior dev or somebody who owns the trunk to take my change and bring it onto the trunk. You can assign things, you can have code reviewers, right? They can see the changes that you made, the commits. If you want to click in here, you can see the exact changes and so on. So this is a spot you can do code reviews. You can actually go in and add comments and so on. But basically, I'm going to create this merge request. And then once that's done, it's going to tell me whether or not I can go ahead and merge this. So right now it's saying the pipeline has to succeed. So it's doing basically, if we go over here to the pipeline, we should see that it's actually running. So it's building my branch, and you can have that branch run and deploy. And in fact, it's completed. So it passed, and now that means that merge request is eligible to be merged, and I can do the same thing on the trunk. So let's go in here. And now you see it, instead of saying merge when the pipeline is successful, it says merge. So I'm going to go ahead and say merge. And now it's basically automatically merged everything into the trunk, and it's kicking off another pipeline to build the combined code. So we can see that running here. So all completely automated. It's going through its various steps, but you get the idea. You can from here have deployments running. In my case, the deploy, if we go to the one that we completed earlier, we can look at that, what that looks like. If we go to the deploy, you can see, oh, that was the front end. Sorry, I want to go to this one, the deploy. You can see it's running that JCL. So you're capturing all of the information that's happening on the mainframe, but in the pipeline. and everything is succeeding. So so we're in good shape. So that's pretty much it. You know, I will pause here. Are there any questions or things people want to see? Hopefully you got an idea that this is a completely viable, and it gives you a great modern developer experience, obviously. So the first question here is from a tool: can the deploys / fallbacks be audited? And so yes, the answer is absolutely yes. In my case, my deploy tool, if you will, is the continuous integration tool. So each deploy, all of the various things that are happening are captured here in the CI tool. But there's also purpose-built CD tools, like say Ansible and so on, and they're going to capture all of the information: who did what, where the binaries came from, etc. And those can all be used for audit. Keep in mind, this is very much like the the process that's going to happen on the distributed side of the house. So, you know, they also have audits and so on. So these tools will allow all of those options. Okay, so there's an
You've got another one as well, Vaughn.
Yep, I see it. So the next one is, what about TeamBuild and SyncZ you mentioned? Are those tools from Broadcom? Yes, so SyncZ and TeamBuild are one and the same. SyncZ is a component in TeamBuild. TeamBuild is a tool from Broadcom, but there, you know, in the interest of keeping it agnostic, I won't say that it's the only tool out there. There's other tools that do builds for mainframe specifically. And it could even just be JCL, right? If you don't, some people just use JCL to do their builds, but there's also tools from IBM. There's a tool called dependency-based build, I believe. BMC is positioning ISPW as a build tool for Git native as well. There's an option to do it that way. So it's not the only tool out there. Obviously, it's the one I chose because that's the one I have access to. But there are tools that do different that do Git native builds. So great question, thanks. Any other questions or things that you would want to see here?
You can also unmute and talk if you want. Okay.
All right. Well, if anybody wants to, they can always reach out to me. Oh, I see. I am restricted to FTP. How can I build? So that's a great question. So if you have no SSH available to you, so in my case, I was using a tool called SyncZ, which uses SSH to drive a build. Now, the other approach that you could have done this with is to get the GitLab CI/CD runner that goes on Z, at least for GitLab, or you could have done it with the Jenkins agent, but basically it lives on Z. You would install Rocket Git on USS, and then you would just clone with Rocket Git right onto the LPAR and done the build. In other words, you would have not used SyncZ at all. You would just use the build tool. So that's an approach. The other approach is, you know, something similar, but with FTP, and then submitting JCL that effectively invokes a script to run the build using FTP for Jazz. Those would be different ways to do that. Are there many companies that do this at scale, either Git native or hybrid? There are definitely companies out there that are doing this in various degrees. I would say it's probably you know, it's really, it depends. There's a lot of companies have chosen the approach to go Git native out the gate, with varying degrees of disruption. I've heard stories that sometimes those are you know, very challenging deployments, but in the end, they are definitely doing this at scale. And same with hybrid. We definitely have people that are doing hybrid approaches. I would say overall, if I was to talk about, you know, the larger companies out there, not the smaller ones, the larger ones, a lot of them are kind of in the getting started phase. So it's not, you know, that's not it's not at scale yet. A lot of the larger companies have more nuances in their processes that they have to deal with and so on. But certainly there are companies out there that are doing things natively, and that's the way that they do their Git deployments. By the way, I apologize for my gravelly voice. I'm getting over a cold for the last week. So, but in any case, yeah, I don't know if I would say lots of companies, but there are some.
Long way to bring you a glass of water, Vaughan.
Yes.
Okay. We just allow a few more seconds if anybody else is typing and wants to ask any more questions. I always find it a lot better. Oh, here we go. Can you see it?
Yes. Where did I get my compile link bar for a COBOL program? So in this case, it's all part of the script. So I think I guess you're talking about, maybe I'm not understanding the question, but where you would have parameters that drive things. Can you fill parameters in? Maybe that's the question. But in any case, whatever is being passed in here for us is coming in through these options. And if you need to drive things with things like parameters and whatnot, you absolutely can. You can pass these in. These little things are effectively parameters. I don't have many here, but for instance, I'm choosing the build scripts that are being run, and I'm passing various things in there. In fact, the way that we use this one is we actually ran a conversion tool that comes with Team Build that builds all this stuff. So it was able to analyze what we had there before and include it as part of the script. So hopefully that answers the question, but if not, feel free to pop me an email and I can maybe get some of our architects to answer the question a little bit more in depth. Yeah, so this is an alternative to DBB. Yep. So DBB is similar to this, and you can pass things in similar. So you would have different scripts, and you can choose the scripts that you want, and you pass in parameters from the driver script, etc. You have some over here that can define the files and so on, but these are all different pieces of Team Build. Yeah. Any other questions?
Okay. I think I'm going to finish myself by first of all saying, Vaughan, thank you very much. I really like the way you sort of did your presentation and then the demonstration. And it's the second presentation that I've chaired today, and it's all gone swimmingly very well, and long may that continue. Yeah, but very, very good. Really enjoyed it. And thank you for bringing the feedback session. What I'm also going to do is put the link in as well. It's 5E that you do. But please, I would encourage everybody to feed in the feedback so we can have Vaughan back to do his, well, maybe a different presentation, but also with a demonstration that flows well. And as Vaughan said, the foils will be on the agenda, and yes, his email is on there and you can contact him direct. And then the last point I will say is the recording for this will be on the session as well, on the agenda. In order to get it, you need to sign in and you need to have been registered for this conference to get it. So I'm going to bring it to a close because unless there's definitely no more questions, appreciate the compliments we've just had. What I will say is at 5 o'clock, we've got the keynote speak from, dare I say, IBM, from Meredith Stowell, and I think Mark is also doing it. But in terms of this session, we're kicking it off tomorrow at 9 o'clock with Anna Chagall from IBM. leveraging the Z16 AI accelerator. Again, she's going to do a live demo, so hopefully that's going to go well, but kicking off at 9. So thank you very much. I'm going to give the last words to Vaughan.
Oh, I'll just say thanks for taking the time to join us today at this virtual GSE. Hopefully I'll see many of you at the real one, the real in person, live and in person in November. So appreciate your time today. Thank you.
Okay, look forward to it. Cheers.
Cheers.